This is Team 23, just skimming by. I'm Garrett, here with Chase, Daniel, Michael, and Samuel. Through this presentation, we hope to convey our project, our first design, final design, the use of the engineering design cycle in the project, and what we've learned from the experience. Our project was to design and build a hovercraft for under $40, excluding parts brought from home. There are mainly two tasks in the design of a hovercraft. Task 1, using either battery or electric power, create a base that with its own weight can lift under its own power. Task 2 is once hovering, have a forward momentum using a secondary pump or fan. The competition for the hovercraft included a 2-foot by 40-foot track, which was tested to have a fastest time for completion with the least number of times going off the track.
When making the design of the hovercraft, we had to take into consideration how the hovercraft works. The mechanics were pretty straightforward in that the air is forced to the bottom, creating a flow of air to allow a hovering motion to occur. When this was established, we had to incorporate a method of pushing the hovercraft in a forward direction. This was easily fixed by implementing a propeller that allowed the hovercraft to head in the forward direction. Last but not least, we added a rudder to the rear to allow us to be able to control the specific direction that the hovercraft went.
The first design of our hovercraft was going to end up using fans and some remote control parts. The problem with that design is that it ended up being way too expensive. The cost came out to around $150 for all the parts that we needed, but that was nowhere near within our budget of $40, so we decided to go with the other design.
After we realized that our first design would not fit the criteria, we turned to the engineering design cycle in order to create a hovercraft that would both function properly and stay within the cost limits. On this slide, we will demonstrate our use of the design cycle shown during our E101 lectures, while on the next slide, we will use the design cycle from our engineering student handbook. We first needed to figure out how a hovercraft works, and to do so, we consulted some sources that taught us the basic mechanisms of a hovercraft. Now that we had a basic understanding of how one would work, we were able to simplify our previous design so that we could make a hovercraft from more affordable materials. We were then able to build a working hovercraft from our new plan, and we took extensive time to test it. After the hovercraft pre-event, however, we had to reanalyze our design in order to improve the handling and make it work on all types of terrain. Our current design thus started with us asking ourselves just how we could make the hovercraft work on a carpeted surface. In the Imagine stage, we discovered that a smaller hole in the skirt would allow for improved lifting capabilities. We also decided to add another fan in order to fix the handling issues that we also found problematic. In the planning stage, we decided to simply use tape to make the skirt hole smaller, so that we would not have to use a new skirt. We also decided that we could just use a fan from a previous design as a means to improve the hovercraft's handling. We were able to follow through with these plans in the create stage without many problems, and this meant that it was once again time to test our hovercraft design. We found that it could now hover a respectable distance above a carpeted surface, and in the last parts of the improved stage, we made sure that our hovercraft would be properly balanced in order to ensure that it could work as effectively as possible. Thanks to the engineering design cycle, we had now built a more economical and effective hovercraft that we are excited to demonstrate during FEDD.
The design that we decided on consisted of 2 air pumps, a rudder, a propeller, and various parts from a remote control truck. As you can see, the trash bag is attached to the bottom of a flat surface that allows air to freely flow to fill the space in the trash bag. After tweaking the design a few times, we felt that we had reached an equilibrium in air distribution, weight distribution, and friction. If we had to design another hovercraft, firstly, we would not add the gnome to the front of the hovercraft. It added too much weight to the front, which greatly slowed it down when it was time to maneuver through the track. In addition, when testing the prototype on tile floor, the hovercraft was easily able to navigate the course. When the hovercraft was put on the testing surface, it was hesitant to move as freely as we had previously observed on the tile floor. A small hole in the top of the trash bag would have benefited us significantly to prevent as much air from the air pumps from entering the trash bag at one time. Also, if we had dedicated more time to equalize the weight instead of the style, we would have been better off.
What we learned during this project is that when you create a design for something, it's not always necessarily the design that you end up using. It requires a lot of different designs that go through a different process, and you end up coming up with the final design that ends up being what you use. And you have to take into consideration all of the different factors that end up, for example, for the hovercraft, that end up determining how well it hovers, such as the weight and the distribution and then the lift. And so we were able to do all this, and the way that we did this was, we had to work together, and so we set a schedule, and we said that we were going to meet on Thursdays at 7 in Tally, which ended up working out really well, because if we weren't able to get all our stuff done for that week, it was only Thursday, and so then we could continue to plan to meet later in the week, which helped a lot. These are the links to some of the sources that helped us learn how to create a hovercraft. Thank you for listening to our presentation.